So let's start with a quick review of yesterday's notes. We were talking about this process called Gaussian elimination, and Gauss said that there were three things that you could do to help you get the process rolling along. One of those steps that you could do is you could switch any two rows at any time. This would be done if you figured out that it would help you in some way. Secondly, you can multiply or divide any row by a non-zero constant. Now, the reason why you would do this is to try to get 1 as a leading coefficient in one of your columns. And third, you can add any two rows together, or you can add any multiples of any two rows together in order to get the zeros. So this is how we're going to get the zeros in the Gaussian elimination process. And multiplying or dividing by a non-zero constant is how we get the ones, and sometimes if we switch rows, it might help. Now, the pattern that we're going to work in for Gaussian elimination is we're going to work from the top down. So we're going to start on the top row first. And once that's all set, then we're going to work on the second row. And once the second row is all set, we're going to work on the third row. And we're also going to work from left to right. So if there's more than one thing to be done on a particular row, first you take care of what's in the first column, then you move over and work on what's in the second column, and so on and so forth. So remember, the goal of the elimination process that Gauss laid out is to get your augmented matrix into something he called row echelon form by using those elementary row operations that we just laid out. Now, what does row echelon form look like? Row echelon form should look like a diagonal of ones going from the top left-hand corner down to the lower right-hand corner, and there should be a triangle of zeros underneath it. This is why it's so important for you to understand what elementary row operations need to be done to create these ones, as well as what elementary row operations need to be done to create these zeros. So we work from the top down, from left to right. So in the top row, first thing you do is you make this a 1. Then in the second row, you make this a 0, and then make this a 1. In the third row, you make this a 0, then make this a 0, then make this a 1. We always follow this same pattern. Now, what do you do when you get into row echelon form? That's when it's time to put the letters back into each row. You actually start with the bottom row, and by putting the letters back into the bottom row, you find the answer for your last letter first. So in this case, z was 6. And then you put your letters back into the top row, plugging in the value for 6 where it belongs as a z value. You can figure out the answer for y, which is your middle column's letter. And then you put the letters back into the top row and work out all that math. So you actually find whatever letter is in your first column last, and you actually find whatever letter is in your last column first. Now, we did work through one full example in yesterday's notes, but what today's notes are going to do is they're going to give you a couple more examples that you can use to help you with the homework assignment that I've assigned for tonight. So in my first problem, you'll notice that this system of equations over here is a little bit smaller. There are only 2 letters, x's and y's, and only 2 equations, the top row and the bottom row. So when I go to make this augmented matrix by pulling the letters out from the x's and the y's, those will go in your first and second column, and the constants of 19 and -4 would go on the other side of this dotted line in your augmented matrix, you're going to notice that this matrix is smaller. The smaller it is, the easier it will be to solve. Now remember, the process is always the same. You always want to start in the top left corner. And what I want to see right here is I want to see a 1. Well, I currently do not have a 1 in that spot. I have a 2. So what I'm going to do is take the entire first row and divide everything by 2. Remember, whatever math you're doing, you got to do it all the way across. So your new top row after being cut in half is going to be 1, -1.5, 9.5. When you're not doing something to a row, you're just copying it over. So the second row, I'm just copying over 4, 8, -4. Now that my top row is good, I'm going to put a little check mark next to it. That's the only thing we have to do in our top row. In the second row, the next thing to do is to try to turn where this 4 is. You're going to want to turn that into a 0. The way you turn things into zeros is by adding rows together or multiples of rows together. Now, if I add the top row with the bottom row, that does not make 0. That would make 5. So what I need to do is first multiply the top row by -4 to add with the bottom row. Remember, I'm only multiplying the top row by -4 to help me change the bottom row. I do not want to make any changes to the top row. So what you're going to see next is I'm going to keep the top row the same. 1, -1.5, 9.5, same as before. When I do my math, I will multiply the row 1 by -4 first and then add it with the bottom row to come up with my new values. So -4 times 1 is -4, add it with the 4, that's how I got the 0. -4 times -1.5 is 6, 6 plus 8 makes 14. -4 times 9.8 is -38. -38 plus -4 makes -42. So that's how I got my new bottom row, by doing this math right here. Now, I'm starting to see that row echelon form. I've got my diagonal ones starting, and I've got my triangle of zeros underneath it. But the next thing that's wrong is where this 14 is supposed to be, that's supposed to be a 1. So I'm going to have to take everything in my bottom row and divide it by 14 to turn this into a 1. So remember, when you're trying to get ones, you're dividing by something. When you're trying to get zeros, you're adding rows together. When I divide the entire bottom row by 14, I'm going to get 0, 1, -3. And I am now in row echelon form because I have my diagonal of 1s and my triangle of zeros underneath it. This bottom row is actually telling me the answer for y is -3. And by putting the letters back into the row above it, I can figure out that the answer for x must have been 5. So in my second example for today's notes, we're going to take a look at a system of 3 equations with 3 unknowns. I've got x's, y's, and z's. There's my constants. That means I'm going to have 3 equations. There's my first row, my second row, my third row. Those are my 3 equations. And the very first thing you're going to do here is turn this into an augmented matrix. So we're going to take all the letters out of here, just use the coefficients on the left-hand side of the dotted line, and on the right-hand side of the dotted line go these constants, 19, 14, and 6. So there's my system of equations written as an augmented matrix. Again, we always start in the top left corner. I need to turn this spot into a 1. So I'm going to take everything that was in row 1 and I'm going to divide it by 2. So dividing 2 by 2 is 1, dividing -1 by 2 is -1/2, dividing 3 by 2 is 1.5, dividing 19 by 2 is 9.5. The next thing I would have to do is to try to turn this spot into a 0. But there's some good news in this problem. That's already a 0. So I don't need to have to make any changes there. The next thing I would want to do is turn this spot into a 1. In order to turn things into 1, you want to divide by whatever number would turn that into a 1. So in this situation, I need to divide my second row by a 2 as well. So the new middle row is going to be 0 divided by 2, which is 0, 2 divided by 2, which is 1, -1 divided by 2, which is -1/2, 14 divided by 2, which is 7. I haven't even touched the third row yet, but already my top row and my second row are all set. This is looking exactly the way we want it to look for the row echelon form. The only thing that's wrong right now is the bottom row. So it's now time to go work on the bottom row. The first thing that has to happen in the bottom row is you want to turn where the 7 is into a 0. Always use the top row to help you get rid of things in the first column. But adding my top row and the bottom row together does not cancel out the 7. That would make 8. So you're going to have to multiply the top row by -7 first before adding it with the third row to help you make this new third row down here. So again, top row and the second row were already the way we want them. We're not making changes to those. But I'm using the top row, multiplying by -7 to add with this to make what you see down here. My new bottom row should be 0, -1.5, -10.5, -60.5. Now, the next thing that needs to change is this spot right here. That spot also needs to become a 0. You do not want to use the top row to help you eliminate that because that would be bringing x's back in. So you always use the middle row to help you get rid of things in the second column. And what I would have to do to the middle row to add with this to get it to cancel out is I'd have to multiply the middle row by 1.5 so that when I add it with this, they would cancel out. So here's what I'm planning on doing over here. I'm going to multiply row 2 by 1.5 and add with row 3. That's going to give me my new bottom row down here. Remember, you're not changing rows 1 and 2. You're only working on one row at a time. So my new bottom row is going to contain the numbers 0, 0, negative 11.25, and negative 50. I ran out of room at the bottom of that last page, so I copied what we were just working on over. I have not made any changes to this. This is exactly where we left off. And I'm almost in row echelon form. You can start to see that diagonal of ones. I've got all the triangle of zeros underneath there. But the only thing that's wrong right now is this spot right here. That spot is supposed to have a 1. So the way we turn things into ones is we divide by whatever number would make this a 1. In other words, I'm going to have to take that entire bottom row and divide it by negative 11.25. You're going to be surprised to find out that this problem actually gives us non-integer answers. So we've got our diagonal of ones and our triangle of zeros underneath it. This means I'm in row echelon form, and that bottom row is actually telling me the answer for z is 4.4 repeating. Now, a lot of times when people see answers that are not decimals, they freak out, they panic, they think there's got to be something wrong. In real life, it's very rare that answers would always turn out to be whole numbers, so don't be surprised if this happens. There's a way you can check your work that I'll show you later, but this is the answer for this problem. For z, it's 4.4 repeating. Now we're ready to do the back substitution process, where you put the letters back into the row above that. So the row above that saying y minus 1 half z is equal to 7, and we know this value of z is 4.4 repeating. So when I put it in here, I can figure out the answer for y is 9.2 repeating. And then you would put the letters back into your top row. 1x minus 1 half y plus 1.5z equals 9.5. We now know the answers for z, which you can put in here, and the answer for y, which you can put in here, to figure out the answer for x. So the answer for x in this problem is 7.4 repeating. You are now ready to try your homework for tonight. Use these problems as an example to help you do the work.